طيب بسم الله الرحمن الرحيم. So today we're going to start the first chapter, and as I said, the first chapter is just to covers the impact or the effect of networking on our way of life. So it covers some applications that we use networks for, whether in our daily life, in our personal life, or at work, and so on. So, at the beginning, as I said before, remember that our strategy is just that we throw the whole picture at you, and then the picture is not clear, and then throughout the time it becomes clearer and clearer. So if you do not understand some of these applications, or you don't have a clear idea about how these applications work, that's okay, because we will talk about them as we go through the material. So as an introduction, of course, the globalization of the internet has succeeded faster than anyone could have ever imagined. So at the beginning, when they have invented the internet, the whole idea was just to have two computers or a group of computers to just share a printer or something like this. There was no vision whatsoever that this would lead to the proliferation of the internet in every aspect of our lives. So the internet has evolved from just a simple computer-to-computer communication, two computers talking together, to human communication, to like having cell phones like this and we use them to talk to each other, or having applications like WhatsApp or something like this, and we use it on a daily basis to communicate with our friends and relatives and so on. So that was not the vision at the beginning of inventing the internet, but it actually rapidly intervened in every aspect of our life in a very fast. So right now, it's in every aspect of our lives. So starting from communicating with like peers or friends or co-workers or something like this, it's in our car. Right now, if you go to any like coffee shop or something, you'll see like we have Wi-Fi, and so this affects the businesses, affects your daily life in a profound way. It's also in our work. So here we have like video conferencing, where we can communicate with other people on the other side of the planet, and we can see them, and in some cases we can shake hands, and it's as if we are sitting in a local meeting chatting together. So that's facilitated through the concepts of networks and networks. Even in our roads, so we have like live camera that feeds the traffic condition to the main office, and they can monitor what's happening in traffic in real time. And right now, for example, we have Google Maps, so it's on our cell phone. So at any point in time, we can just see how the traffic looks like in real time. So it gives us a snapshot in real time about how traffic jams and these kind of things. So this is also facilitated through like the networks or networking equipment through the internet. So all of these things, these are facilitated by like some, let's call them soldiers behind the scene, that we don't actually see them, but they are working to make this happen. They are working for you, and you don't see them. These are what we call the networking devices, or switches and routers and things like that. So even if we talk about cell phones, we know that cell phones are wireless, but at the end of the day, they have to communicate with the base stations, and base stations eventually they have to communicate through switches and routers in order to make the end-to-end communication happen. So these are the soldiers that, even though you don't see them, but they are working for you to try to make the applications happen. So many concepts are used to make this routers and switches to talk to each other, which we will learn throughout the course. So, so there are some cables and stuff that hooks up these switches and routers together. There is some configuration that needs to happen, which you will learn some of them through the lab. There is the concept of security, of course, which is very important, because if we don't have these networking devices secure, chances are someone will tap into these devices and will destroy your whole network and disrupt your communication significantly. Of course, privacy, your information is flowing through this network, so it has to be secure and preserved. The concept of availability, which is very important. So we have encountered several times that there is like a network failure in the network of the university, and all of a sudden all the services that we are used to using on a daily basis, they are not working. So there is the concept of availability, which is a very important aspect in networking, that if you want to increase your availability, there are some precautions and some things that you can do in your network to make it more available and more robust. Quality of service as well. This is different from availability. Availability talks about failure or working, but quality of service, everything is working. But when I start this video, I see like pauses. I don't see the video with very good quality. So the concept of quality of service is very important. So I need to have video on demand. I need to have, whenever from anywhere, I can watch the video, and I should see high definition video with no like delays or no pauses or no interrupts and so on. There's voice over IP now, so instead of using the landlines, we can just use our network to have the voice over the LAN or over the network of the university. So here in our offices we have the Cisco sets, telephone sets, which actually does not use the normal telephone network, but it uses the network of the university to have voice communication between the different telephone sets. So this redundancy is related to the availability. So if you have redundant, means that you have your network working, but you need to increase the number of routers and switches as backup. So if one router fails, you hook up the other one automatically and seamlessly in such a way that the user doesn't feel it. So this way you can enhance the availability of the network. Okay. So in case of failure, you can switch to another router to make it more robust and so on. Mission critical applications, like if you have like disaster recovery situation or something like this, and so you have like a very drastic event, and your network is mostly damaged. So how can you support your application, or some applications related to military or something like this? So how can you make these applications work in a very high quality manner? Productivity and user expectation. The user has some expectation in terms of the quality of the video and audio that he or she would actually see, and we need to have this quality of expectation or quality of service supported in our network. In addition to that, of course, we have wireless, which is very this is like the trend, or like the most significant communication medium that we use nowadays by far. So we need mobility. We need to have everything wireless. and everything available at any point, at any location, and at any time. So we need to be mobile, and at the same time we need to have high accessibility to all services without having to really hook ourselves up to a cable or something. So that's facilitated through what we call wireless. So we'll get some idea about each of these concepts throughout the course as we go through. But each of these concepts, they require some interaction between the networking devices at different levels, and we will learn what these levels are and how they interact together. As we said before, the network is just evolved from a normal, computer to computer, just to share some devices over the network. So it evolved to people communication. So we actually evolved from like a character based communication. So we only need to write simple text or print some characters on hard copy papers or something like this from one computer to another. And that evolved to very sophisticated ways of communication that facilitates not only the text-based communication, but also voice and video and graphics and all these types of information. And we can encode and we can translate this information in such a way that makes it, flexible to be communicated over the networking devices. So today's networks, they carry or they support many different services which are very, very wide variety. So we have voice, we have video, we have text, we have graphics, which is what we call nowadays like multimedia. As we will learn throughout the course, that to be able to support each of these types, you need to have certain aspects or certain protocols and designs in the network to support each of these types. We cannot just deal with them as one type of information. We have to deal with them differently and separately. And we will see throughout the network how we can give each type of these services different like routes and different ways in the network that makes the applications efficient. We'll learn many of that in the. So nowadays we have very sophisticated communication tools that we can use simply to do anything, to transfer video, to have like simple communication through text, to have voice to voice communication or voice calls. So we are finding it easier and easier to just use, like, for example, WhatsApp for our text, and at the same time just click and have voice calls over WhatsApp. So some people, they feel even lazy to switch to another application to call through the phone, through the normal phone, through the cellular network. You just click on WhatsApp and have a voice call on the same application. So which of course uses a different type of network altogether. But for you, it doesn't matter. As long as I can make my phone call going, I don't care. As long as the voice is heard clearly and I can do my communication normally, then I don't care whether this uses cellular network or this uses IP network or internet. I don't care. So the network is actually evolving, the internet is actually evolving, and the bandwidths and speeds are growing very, very rapidly. That makes all these applications possible and seamless for us, which was not easy at the beginning. As we will learn throughout the course, this was not easy at the beginning, but now it's becoming more and more widely available. So different ways of collaboration through like social media or Facebook or blogs. Of course, some of you're not familiar with blogs, but some of you maybe are. So blogs was like the beginning of like some social media. So blogs was just the initial way for collaboration between different people to kind of form like an article or something like this through the collaboration between multiple people. So now we have, of course, Facebook and Twitter and these kind of things, which are much more sophisticated and much more widely used. So wikis, of course, is another way for creating something very humongous, very huge, through the collaboration of people. So in the past, the concept was that one developer would just create a web page or a website, on his own, and then the content of this website becomes pretty much static. So you can log on or you can go to this website and see the content and browse through the content, and that's it. And that was limited in terms of the amount of content that you can put on the website. But now, with the widespread of social media and blogs and these kind of things and wikis and these kind of things, the content of the website is actually being created and generated from different people at the same time. So you just create a framework that people can use to collaborate to create the content. And that concept is really revolutionary because the amount of content that you can put on the website, it's like you're talking about millions and millions of gigabytes that can be generated in minutes or few hours. Rather than just having one person creating the content on this website. So the amount of content is very limited. But if you allow millions of people on earth to kind of pour some content to the website, the impact is huge, and that's what's happening nowadays. So wiki is like you can create an encyclopedia about a certain topic, okay, in like few days or few months. So encyclopedia, you're talking about huge amount of information that has to be generated. But through wikis, you don't have to do that, using few people, few developers. You can just create the framework and allow people to collaborate to generate that content, but give some restrictions and some mechanisms for these people to use in order to create the content. Okay, because you need the content in a specific format and specific way. So that's what's happening now. So you give people, you give them some limitation and some boundaries, okay, and you design that framework and make it widely available for people. So people would now, they log into this website, they create content. Not only that, they can actually use their energy or their bandwidth to verify others' content. So throughout the time, you can not only generate huge amount of content, but you can actually throughout the time you can verify and make this content clean and robust and reliable for people to use. And that's why nowadays we have like wikis, we have Wikipedia, for example, huge encyclopedia about lots of things. So you can create a huge amount of information through the collaboration between people. So that concept is really fundamental. Okay, it revolutionized the way the internet content is actually created, and that's why nowadays social media is just is consuming significant part of our time on a daily basis. So there is we have the internet, right? And the internet is a group of small networks, right? There is the concept of intranets. So whenever we use the term intra, this means that we have So when we say the word intra, this means that this is inside that that domain. Intra is something internal. Okay. Enter means that we have another like group of these, and they communicate and they collaborate together. So so the concept of intranets, these are private network, okay, which it has some interface to the internet, but inside the intranet, it's very secure. No one can get inside except the ones that are authorized to do that. Okay, and that's usually used by companies and like here in the university, even you can consider our network university as intranet. Why? Because you cannot just get inside the university network from outside, at least easily. Although some people they hack and stuff like that, but in normal conditions, you cannot just get into this intranet easily. Okay. Another example is just you can imagine that Microsoft or Apple or these big companies, they do not expose their machines and workstations and put it on the internet like that. They cannot do that, of course. So within Microsoft there is like intranet, okay, and by saying intranet, we mean like a small network that covers like a building or something like this, and it's closed. Because extranet is nothing but a group of these intranets connected together. So, for example, like Microsoft, they have intranet, for example, in Los Angeles. And they have intranet in another location. So when these intranets, they communicate together, they form what we say extranet. Why we don't call this intranet? Because extranet is still closed, okay? It's not bound by a geographic location. So you can connect the intranet in one country with an intranet in another country, but they still, both of them are closed. And they should have very secure connection between the two intranets, okay? But still, they are not exposed to the internet. Or, I mean, you can imagine what would happen is that I can get, for example, the source code for Windows 10 and can do whatever I want, well, which doesn't make sense, of course. So these intranet are closed, secure networks, okay, and of course they have some interface to the internet. So, but through some secure links that protect the communication inside this intranet, okay? And then we have the internet, which is a connection between group of intranet with normal networks, which are not secure, and these are networks that can communicate together. If I want to communicate from an intranet to the internet, then I need to use something like VPN. We're all familiar with VPN, right? So we can communicate through what we call VPN. VPN or virtual private, or some secure communication. We'll talk about that briefly. But you need to have like some secure link to the internet. So if you want to communicate from an intranet to the internet, you have to go through that secure route. Only one or two secure routes, which will allow you to go out to the internet. But you cannot just, from the internet, you cannot just get in the internet easily. So it's very secure and closed and private. It's like in your home, it's private. No one can enter your house except with very, very strict conditions, right? Except some people who are authorized to do that, right? So these people, they can use a VPN to get in or VPN to go out, okay? Through their authorization. But other than that, the normal people, they cannot just get into your house or they cannot get into the intranet with no authority, okay? So this is so we have intranets, we have extranets, and we have the internet. The internet is just the global network that connects everything together. Okay. So starting from here, we can talk about the communication system. What are the very basic components of a communication system? Okay. So it turns out that we have any communication system has 5 components. Okay. The communication system has like a sender who is the entity, we don't call it like a person or a machine, it can be anything, that initiates the information. Okay? So I want to, when I speak, I'm now the sender. Okay? So I'm producing some information that goes out to people. And then we have the receiver, of course, which is the entity that receives that information. Right now, in that example, it's you. So all of you are receivers to the information that I'm currently giving. And we have the medium. The medium is just the thing that the information flows through. This medium could be wireless, could be a cable, it could be optical, could be anything. Okay. And we have the unit of information, which is the message. This message could have text, could be voice, could be graphics, could be anything. So these are 5 different components. These are tangible components, and we can see clearly that we have these 4 components. What we don't see is actually what we call a protocol, and this is the most important component in the communication system. Okay, so before we start communicating, we need to have a protocol. A protocol is a set of rules and regulations based on which you start the communication. So, for example, if we set the rule that I talk in Chinese, okay, then I need to make sure that when I talk Chinese, you understand Chinese. Otherwise, we will not have proper communication, right? So, like for example, in this particular example, if I go to communicate with someone and he will do like this, and I don't understand what this is, then there's no proper communication. But if we know that, before we talk, we have to, for example, like shake hands or say Assalamu alaikum. So these are like implicit rules and regulations that we have to do in order to make the communication efficient. So that's what we call a protocol. It's like a set of rules that has to be fulfilled throughout the communication. Otherwise, I'll talk English, you talk Arabic, you don't understand each other, we cannot talk. Okay, so that's the most important component. So these are the 5 components of any communication system. So the definition of networking, this is like a textbook definition. So the networking is the interconnection of workstations and peripherals and terminals and other devices. So we know most of the things, but other devices, these are the real networking devices that we will talk about, which are like routers and switches. These are like behind the scene soldiers that, as we said, they make the communication happen. This is the former definition from whatis.com website, which is, I think, more descriptive. So, in information technology, networking is the construction and the design and the use of network, including physical devices such as cabling, hub, and bridge and switch, router, and so forth, the selection of use of telecommunication protocols. And this is the most important things. So if these devices are put together or connected together without having the proper protocols to talk to each other, they cannot form a network. Okay? As we will see later, unless you have the same protocol in every level of networking, the communication will not happen. Okay? So the use of protocols is very important, together with computer software for using and managing network. And that's also very important because your network card is a hardware, but it runs some software that implements these protocols in order to communicate. So that's very important. And the establishment, operations, and policies. Policies, which means that if you misbehave, we'll kick you out, something like that. Some strict rules that applies throughout not only single device-to-device communication, but it applies through policies. It applies through, like a network, a big network. It's like global policies, global rules of communication. So if one device misbehaves or gets hacked or something, we'll kick it out of the network, just not to affect others and so on. Okay? And procedures related to the network. So that's the formal definition of a network from whatis.com website. So these symbols are very important. So we will use most of these symbols very frequently throughout the course. So you do need to get familiar with these shapes. So when we have like a workstation like this or a laptop, we usually mean like this is like a client. We'll talk about what client is. This is a server. That's how it looks. iPhone, of course, IP phone. This is like a LAN or a cable. This is like a physical cable because wireless has a different symbol. So when we have this symbol, this means that this is a LAN switch. We'll talk about what LAN switch is. This is a firewall, and most of you are familiar with what firewall is. It's something that protects the network. Okay? This is a router, and this is wireless router. So when we have these antennas connected to the router, this means that this is a wireless router. And we have a cloud which represents a network. Okay, so that's if we want to represent a network in abstract way, so we call that this is a network and this is a network, and they communicate together. So we usually use the symbol cloud. For example, this network is formed by like one router which is connected through a cable to another workstation and connected through a cable with another IP phone and another TV or a display or something. This is the symbol for the wireless medium. So this is a wireless medium and this is a wireless router. So this network is basically wireless, and wireless router has some cable port as well, which is connected between two routers. So those two routers, they form like separate networks, and these two networks, they communicate and they connect together. So that's how we use these symbols in a combination to try to show you that how this network consisted of and so on. This is, of course, how the cable looks like, and we're all familiar with that. And in the lab, you'll talk about how to actually connect the wires inside it, even how these wires are connected and how they form this cable. So that's the hardware. In terms of software, we have the network applications and protocols, and we will talk about many of these protocols in details in later chapters. So we have the www or the web, and web uses what we call HTTP. low hypertext transport protocol, which is one protocol that we use when we deal with the web browser and so on. So we will talk about that in details. We have emails, of course, which can use SMTP and POP and things like that. So we'll talk about these in details as well. We have the instant messaging, and we have the IP telephony. These are just some assorted set of protocols. Okay, so when we say protocol, this means that these protocols need to be supported on both the sender and the receiver in order to be able to communicate. So, for example, if you use HTTP on one side and TCP on another side, they will not talk. They cannot talk. So we have to have the sender and the receiver using the same protocol in order to communicate. Same thing, we have some application level protocols like DNS and DHCP. Some of you are familiar with some of these protocols. If you're not familiar, that's fine. That's perfectly fine. We'll talk about them throughout the course. But these are application level protocols. But we will study not only these protocols. We'll study some lower level protocols like TCP and IP and these kind of things. These are low level protocols, not in the application level, but even underneath. And we'll talk about how these protocols are actually designed, how they work, and so on. So the architecture of the internet, when we talk about architecture, this is like what is the global view of the internet? Okay, so as we said, the internet is nothing but an interconnection of groups of networks. Some of these networks may be intranet, extranet, LANs, WANs. We will also talk about LANs and WANs and these kind of things. Different types of networks, and they are interconnected together. Interconnected through wires, through wireless, through optical fibers, whatever. Okay? So this is the main, so the internet is just any interconnection between these networks. But the issue here is that these networks should be hierarchical in a way that makes the internet scalable. يعني ايه بقى قضية scalable? What scalable means? This is a very important feature that makes the internet what it is today. It's very important because without scalability, this means that when you add more and more devices and machines to the internet will become slow, or it becomes, not efficiently operational. Okay, so scalability here means that when you expand the internet, it does not affect negatively the current machines or the current networks that we have. Okay, this is a very, very important feature. So, for example, to understand the concept of scalability, if you have maybe let's talk about a very simple example. One teller in the bank, okay, and he has a number of customers every day, like maybe 10 or 12 or 20 or something like this. So each customer will take, few minutes or 2 or 3 minutes and so on. So one day, all of a sudden, he found that he has 3,000 customers. So the wait time for each customer, of course, will increase a lot, right? So that example is not scalable because you have one server, one person who's serving everyone, and by increasing the number of customers, the current customers will be impacted badly. So that example is not scalable. Okay? Another example which shows you really how scalable systems could be is, for example, YouTube. This shows you really how scalable systems could be. You can imagine the amount of videos that are, being poured every day, and you don't care where your video is stored, right? In fact, whenever you try to upload a certain video, it gets stored in different places. But you don't care, right? So it's that scalable. So if you have thousands of people are pouring video at the same time, okay, what happens is that YouTube will separate this and will store them on different locations so that you can have the same experience like any other person who's currently uploading the video at the same time, and you don't feel it. So your limitation is actually your own connection. It's just not YouTube connection. So even though it's like it looks to you like it's one server, YouTube, you just get into YouTube. But in fact, behind the scene, there are so many clouds and storage, millions of storage devices that serve you behind the scene. You don't see them. So when you upload videos, you upload them on different locations, and you don't care where your video is located, as long as you can access it and other people can access it. Not only that, they have huge amount of streaming servers and stuff like that behind the scene that when you click on your video, it plays very fast. And if you have like 70 people are displaying the same video, they get more or less the same performance, right? So if you have thousands of people are watching the same video, they get the same performance, which is really impressive. So that's an example of how scalable system could be.
Doctor, so to make the system scalable, we need to have many services?
Yes, many servers, and which is what we call redundancy. So you need to have many servers, but not only that. Not having multiple servers and that's it. You need to design things separately, differently, because you need to have dispatchers and you need to route my request to different servers. Okay?
Same request to different servers?
No. Multiple requests. Oh. So in 1 minute, you have received now 500,000 requests, right? So these requests, they need to have the same performance. So in order to guarantee that same level of service, you need to get these 500,000 requests and dispatch them to different servers so that you feel like it's the same performance, same behavior for all of you at the same time. So that's what we call scalability. Okay.
So it's like.
So the internet itself, in terms of interconnection of networks, is built with that concept. It has to be scalable. It's not when I add computers, the current ones gets impacted or gets affected. There should be no effect. Of course, in many cases, as we will learn throughout the course, there is some effect. But we should try to make that impact as low and as small as possible.
So it's like classification for service or request?
No, it's more than that. It's more sophisticated than that. There are so many things that have to come together in order to make this happen.
If you want a video over internet, it goes to separate ways.
No, not only that. Even if you have video over the internet, but you have 500,000 requests of video content coming to you in 1 second. Okay? How can you serve those? So you need to get these requests and have very efficient tools to dispatch them into different locations and sometimes maybe streaming of your video is coming from China. You don't care. Okay? There is a cloud in China with streaming server. You don't care, right? As long as I'm getting the content that I need and I'm streaming the video and I can watch it with very good quality, I don't care whether it's coming from here or there, right? Yeah. And this is the beauty. This is how the scalable system looks like. Okay? Okay, so we'll stop here.